Welcome. In this mini lecture, we're going to cover the key ideas from section 3.4. Those are Pascal's triangle and the binomial theorem. So let's begin with Pascal's triangle. Pascal's triangle is a way that we can figure out coefficients of a binomial. It begins with the number 1. The second row also contains a 1 and a 1. In the third row, we'll have 1, 2, 1. Our next row will be 1, 3, 3, 1. Here, as we are continuing down, you'll note that to generate the new entries, we add the 2 entries above it. Each row begins and ends with a number 1. So our next row would be 1, 4, 6, 4, 1. And we could continue this pattern as long as we want. Now, as it turns out, each row of Pascal's triangle is related to the choose function that we saw last time. So, the first row corresponds to 0, choose 0. The next row corresponds to 1, choose 0, and 1, choose 1. Next, we would have 2, choose 0, 2, choose 1, and 2, choose 2. Continuing this pattern, we would have 3, choose 0, 3, choose 1, 3, choose 2, and 3, choose 3. So we have a correspondence with Pascal's triangle and what are known as the binomial coefficients. So what does Pascal's triangle give us? If we were interested in saying we wanted to expand x plus y cubed, we would look at the third row of the triangle, and that will tell us our coefficients. We would have 1 times x to the third plus 3 x squared y plus 3x y squared plus y cubed. So this allows us to quickly expand binomials for any power we could imagine. Now, the relationship that we see where we're adding the two entries above in the row above to get the new row can also be expressed in this key fact. N plus 1 choose k is equivalent to n choose k minus 1 plus n choose k. So let's examine why this might be true. So let's suppose we have a group of 28 people. Then a new person arrives. We'll call her Anna. Now, let's also suppose that we want to know how many teams of size 7 we can make from this group of people. So, certainly, once Anna has arrived, we have 29 people, and we're going to choose 7 of them. This is the left-hand side of our equation. We have 29 total people. We want teams of size 7. Now, another way that we could think about this is given to us by the right-hand side. On the right-hand side, we'll first consider all the teams without Anna. So teams without Anna are given to us by, there's 28 people, not including Anna, and we're going to choose 7 people to be on the team. But we could also have the teams that definitely have Anna, in which case we're no longer going to choose 7 people. We're instead only going to choose 6 because Anna is already guaranteed to be on the team. So you will note now that the left-hand side and the right-hand side both count all the possible teams that use 29 people. And this is the same logic that's used to determine the subsequent rows in Pascal's triangle. So, as we noted, Pascal's triangle tells us the coefficients for any binomial that we want to expand. This is given in the general form as the binomial theorem. So for example, we might be interested in finding the coefficient of x to the 12th, y to the 5th, and 6x minus 5y to the 17th. So, using the binomial theorem, we can find that coefficient by noting that n, in this case, is 17. The coefficient of x we're looking for will involve the 12. So we need 17, choose 12. The first term is 6x to the 12th power. Then we need negative 5y to the 5th power. Note that the sum of our powers between the two terms must add up to 17. So, now that's the entire term. Since we're only interested in the coefficient, we'll just take 17, choose 12, 6 to the 12th, and a negative 5 to the 5th. That's a very large number. We're not going to multiply it out. But in that form, we know what it would be. That's all for now. Thanks for listening.